Today we will be talking about Ieee 802.11Ax, High Efficiency Wlans, an article by Boris Balata. Volume 23, the 2nd of March 2016, pages 38 to 46. 802.11Ax is the next wireless communications standard in the Ieee series of 802.11 standards, which form the basis for the technology we generally call Wi-Fi. The current 802.11 standard is a cost-efficient solution for wireless internet access, and while it may satisfy most scenarios, there are two areas which it can improve on. Firstly, supporting dense areas with a huge population of users while promoting higher transmission rates has yet to be achieved. Secondly, the era of real-time high-def audio and video content will significantly increase users' throughput needs. Wlans currently use carrier-sense multiple access with collision avoidance is its MAC protocol. Providing high data rates in ultra-dense areas requires many access points to be deployed close to each other. In such dense areas, the main problems are interference issues, which increase packet error rates and decrease the number of concurrent transmissions in the area. Furthermore, multiple stations in the same area increases the chances where the back-off counters clashes and causes a collision. The new 802.11Ax standard seeks to address these problems by developing new physical and medium access control layer enhancements. There are four key requirements for the new standard: coexistence, higher throughput, energy efficient, and backward compatibility. There are four new features that 802.11Ax will bring to the table. The first is spatial reuse, which introduces dynamic adaptation of the transmit power and clear channel assessment thresholds. By reducing the used transmission power and CCA thresholds, the WLAN reduces its influence area, which improves spatial reuse. Beamforming can also be used to concentrate the transmitted energy towards the desired destination to improve spatial reuse, as other nearby devices with a different direction will observe the channel as empty and start their own concurrent transmissions. The second feature is temporal efficiency. The CSMA/CA channel access scheme has a lot of overhead due to back-off countdowns, packet headers, and interframe spaces. 802.11Ax can mitigate these overheads through packet aggregation and piggybacking ACKs along with the data. The use of automatic repeat requests to reduce time spent in retransmissions has also been reworked. Also, simultaneous transmit and receive, full duplex communication will be used in 802.11Ax at all times, allowing the CA feature to be changed to collision detection, as collisions can now be promptly resolved. Lastly, the CSMA/CA protocol will be reworked to minimize collisions by using a deterministic back-off after successful transmissions. The third feature is spectrum sharing, where dynamic channel bonding will only use the available channel width at each transmission, which will enable adaptability to the instantaneous spectrum occupancy. Orthogonal frequency division multiple access will add flexibility to the usage of spectrum resources by dividing the channel width into multiple narrow channels, which can then transmit to multiple users concurrently. The last feature is spatial multiplexing using multi-user MIMO, which allows for multiple concurrent transmissions to different wireless stations from an access point in the downlink, as well as from multiple stations to an app in the uplink. By combining it with OFDMA, MIMO can multiplex even more users within the same channel bandwidth, making it suitable for dense environments by providing all users with smaller but dedicated sub-channels. In addition, there are further planned amendments for 802.11Ax that have not been implemented yet. The nominal data rate of 802.11Ax over 802.11Ax is about 37% higher, and the user throughput will increase by up to 4 times due to its more efficient spectrum usage. In conclusion, there are still challenges to face in order to implement 802.11Ax. For example, multiplexing so many users under a single transmission will result in reduced receiving power per hertz and possibly longer transmission delays. In addition, certification will take a long time, with an expected date of 2019. However, once adopted, pervasive computing will become even more ubiquitous, with the ability to support large amounts of concurrent users at a higher throughput.
Video created by Zhong Han, Linus Lim Ji Wei, Han Beng, Ong Shu Wei, Tian Wen. Thank you.